In this chapter, I will tweak the simulation and make sure it's looking good. In the last chapter, we was talking about the simulation result, and we have like this example, intersection here, and I think this easy fixed and lower cost to fix it in Anim. So what I did, I have a new animation, and I will update this with a new animation. And this animation, as you can see, this is a new version, and this how it was before. I asked animation to move the leg a little bit, so we have no intersections. Also, we moved the leg a little bit, the hand, sorry, because it was intersecting with the bag, and this way we avoid this issue, and we have much more cleaner simulation. Okay. By updating the animation, because all this based on the animation, so maybe some of the remesh will be updating and causing us a new point count. This, if we have a dynamic simulation, like if we have a selection by point count, this way we have to update it. If we have selection by like lasso or group bounding box, it will be not affected like this. It's updated, but it's still the same selection. But we have here, I think, I remember we have some of the selection is based on the point count, and this is not good. But I wanted to make sure you are aware of this and to update it. So I will select based on the Iceland and select these parts and update them. Okay, I think that's one is only the one we have based on the point count. Let's see this one. Okay, this one is not affected, no change. And this is based on bounding box. Okay, not a big deal. All right. The second thing I wanted to do is updating the layer number, because I like to add a layer number more realistic and reorder it. I feel this order is much better. So I will reorder the layer. For example, I will keep this like a 20 because this is on top of everything. So I will make sure it's like the bigger number, and this one is this in the same level. So let's go. This one is 1, and this 3, 4, 5, and so on. Then 11. Okay. So now let's start one by one and updating the bands first. So I have here bin to anim. I like to make this keep this bin and make this a soft bin. So when we have like a lot of pressure, this try to slide and move back and forth. So I will convert this to soft and I'll call this soft. And first I will remove this and this from this selection, and in the soft one we remove the first one. So this way we have two bin. I will update this to soft and this none. Okay, we should have two. Okay, this is not updating. Here we go. And lower this like 100,000, and I think this is good. Okay. Also, we have to update the attribute stiffness and bend stiffness, and also the thickness. I feel the thickness is a bit low. We have to increase it like 0.5. I will increase the thickness maybe on all of the layers, so we have like a good gap between all the layers, so it's not like going inside each other. All right, and also I will decrease the damping ratio to 0.005, and also I will reduce the wrist length to 0.92, so when it's like draping down a little bit, this way we are maintaining the shape and it's not stretching too much. I will add like a compression stiffness 1000, the default one, and also I will reduce the bend stiffness because I feel it's bending too much to 0.01, and I will increase the wrist length on the bend stiffness. In this way, let me show you. Let's add more substance. When I increase the wrist length here, it tries to maintain the original folds and keep them. But if we go like 0, for example, it'll try to go flat. And we lost all the original folds. It depends on what you like, but I like to keep some of them, so to have the look of original shape of the band. But also this will be bending, so when we have like moving, this will be flat. It will try to keep the shape, but this will not like following like a soft body. This will be moving dynamically, but this way will increase the stiffness and try to maintain the original shape. So let's go to the next one. And this one also I will make sure we have a thickness is good. It's 0.5 like the pants, and in the bend stiffness, all this is looking good. Okay, that's right. So I don't touch any of the parameter, but we just updating the thickness here, and after that we go to this one, which we have to update the here the drag. I want to make sure it's dragging a little bit behind, and I will increase also the thickness. Shirt also the same thing. Okay, and the side panels. For side panels, I have to increase the amount of glue, and I will add a stress of volume constraint, so we try to maintain the shape between these two pieces, like two sides, because sometime in the simulation we saw the two sides overlap each other and causing us some of the issues. So I will add a volume constraint, or we can copy from here. And this, I will add like 1.9, so we have more points, and increase the constraint point to, for example, 50. So we have more constraint between each of the sides, and I will increase the stiffness and make sure it's having the default damping ratio. I think with this way we will try to maintain the original shape and avoid any intersection between two sides. Also, the glue is looking good. We have all glue between all the sides, but we can increase this maybe to 9, so we can have more glue on this side. Okay, for the bag, I think we are going to convert this to VDB and try to make sure we have like it as one block or as one piece. So let's try to do it. I will add a VDB from polygons. We'll pipe this directly here, and we'll add VDB 1.5. I think this is not enough. 1.002 is good. Fill interior, and we'll add a reshape to fill like there's like a black, maybe sometime it's gaps between the polygons. So we add a reshape elite like 0.5, so we make sure we are closing all the gaps. After that we convert this to VDB to polygons, and after that we are going to poly reduce this, because if we remesh it directly we'll have like we have to go so much, and after that we reduce it. So we try to do it with poly reduce directly and see how it goes. Poly reduce, and make sure it's equalize length, and let's go like 20% and see how it goes. This is looking good. Let's try and go a bit lower. Yeah, it's higher, the amount of primitives. Let's try to go 15. I think it's pretty similar to the original one, and this is much better. So after that, we have to attribute transfer the original path attribute, because this is important. We have path because we are deforming based on the path, and the path attribute is important. So we try to have the path attribute with us all the way. That's limbic path is, and see if this transfer. Okay, it's looking good. I'm transferring the attribute kinda good. And we don't need this name attribute. Let's delete it. Okay, let's rearrange this. Cool. Now, as we say from the beginning, we like to have more freedom on the bag. So I will kill this and draw a new one with less bin to anim. So this area will be only bin, and all this blue will be free to simulation. Okay. Now I will convert this to calculate uniform, and will decrease the density to 0.001, and I will try to increase the thickness here, like 0.5, or we can go a bit higher, 0.75. This much better. Like, we try to avoid intersecting and make sure we have like this gap between the other geometry. Okay, and I will update the drag a little bit, so we have some drag like the claw. Okay, I think this is looking good, and now we'll make sure we have a good stress attribute now, because we have one geometry. I think this will work much better in the stress volume constraint. So I will increase the constraint per point, and I will increase the stiffness. Also, I will reduce the damping ratio to 0.005. I think this is looking good. Also, I will add another one. And this one will be based on this area only. So what we are trying to do, this, convert this area and this area, will increase the direction jitter to 1 and ray offset to 0.1. So now we'll have like a constraint between the bag and the handles. So because we will have like a stretch from the hands, because this is all this will be depending on these two. So with this way we are trying to help the constraint to keep together with each other with these constraints. We can increase this to have more constraint between these, so you can play with this also, so you can have a new like more constraint, but we don't like to have between each other, but we like to have from the bag to each one of these. So point one is good, and we'll make some damping ratio like 0.01. So we have like like we give it a little bit of freedom to move. It's not to be very stick to this. If we go like this, it will be more strict to this. But when we are increasing the damping ratio, so this way will have like a little bit of gap to go back and forth between the constraints. Yeah, I think the glue we don't need anymore, so let's disable it. And yeah, that's it. Also, I have an idea of, because I when I did some test, this was stretching too much, so I will try to move this and recalculate the stretch stiffness based on that. So we have when this stretch, it try to maintain the original shape. So I will add a venom rest blend. Okay, and this will add soft transform. I will move to center. So let's select this. Reduce the soft relief like this. So this way we are shorting the handle length, and we calculate the stretch stiffness based on that. So this way when it's stretch, it will try to maintain the original shape. But if we keep it like this and when stretch, it will be stretching too much. But this way, when this will be stretched, it will go back to the original shape. So let's imagine it's stretch. So it's stretch to like the original shape. So this way we are maintaining the original shape by doing recalculating the rest length on the stretch stiffness. I will do it on the other side. So now we're calculating the stretch stiffness based on this. And we'll make sure this is only calculating the stretch, not the bend stiffness. But the bend stiffness no change, but yeah, we'll make sure we are calculating only on the stretch constraint group. Okay. So now it's not changing the shape. This is just for calculating the rest length on the stretch stiffness. This is really useful when you have something like this, or you like to make something in the simulation bigger or smaller. You can, yeah, you can do all kind of stuff based on this. So this is the rest geometry, the new rest geometry, and this will recalculate the rest systems. And you have like a blend, so you can blend between the original and this one. If you like to go 0.5, for example, if you feel this is too much, or you can reduce it here. Okay. Now we have, let's see what we have to update. Okay, we fix the bands and we add, okay, yeah, I remember now. We have to release this from the shoulders, and we make sure this is moving freely and not bending to or gluing with the shoulder. So let's go to, yeah, this frame. As you can see, this is, we have a glue between these pieces to, and this is not looking good. We are going to have a glue here because the shape of the clock is looking like we have like something bent here. So I will add a group here and I call it side pin, and we make sure this is bent to, it's not bent, it will be gluing this to the shoulder area. So let's do a new group. Okay. I will call this side bin, and this will be points by bounding sphere, and okay. Let's template this and see how is the original shape with the shoulder. Okay, I think we have to go a bit higher. Of this side. Let's decrease it a little bit. Yeah, this is looking good. And we will use this group to glue this to shoulder area. And all this will be freely moving here. Okay. So I will go to this group. Yeah, we should go to this one when we have all of this. Okay. Now we are going to exclude this log from the target group, and we don't need any glue on this, and we will do another one only on this group. Where is cloak side pin? Let's remove everything first and then add it. Okay, now everything is, because we have a distance, everything is gluing with this area. So now we have this free to move all over, and it's only gluing here. Okay, cool. Now the last thing we have to do is fixing intersections between all the pieces. So if you remember, we add the soft transform here to fix this and avoid this intersection from each other. And when I did the simulation, I find out there's another intersections. Let's copy this and come here. As you can see, we have this is intersecting with this and this intersecting with this, and this is not good in the simulation. So we will make sure we are avoiding this intersection. I will do it really quickly and fixing this intersection between these pieces, because this is a tedious task. Also, I will move this from here to here. So, to here. So when we are updating something, or we are, for example, when I was doing debug, if you go here and we remove this from the merge, and we after that do like a soft transform, maybe if that point number is matching one of these, it will making an issue in other one. So this, after the merge, we don't like to change anything in the geometry. So I will kill this here and start doing and fixing all the intersections between all the geometry. Okay. Okay, so here we go. I did update all the fixes. This should be fixed by modeling or surfacing, but I don't want to take to your time on this, but I will show you what I did here. So, like for example, this was intersecting with this one. Let's see. This was intersecting with this, you see here. I like soft peak this to inside, and also this one was intersecting with the back and the side panels. So this is a tedious task, and I move these a little bit inside each other and make sure there's no intersections, and also the back was intersecting with this, with this, and if we see this and disable this, we can see the bag was going inside the tank, and this is not good. Also, I move the cloak soft transform to this area and make sure it's outside of this, and this way we'll try to have as much as possible a clean simulation, and we avoid all this intersection or unwanted intersections this will cause us an issue in the simulation. Also, the last thing I wanted to add here is I want to add a delta mesh. This will smooth out the geometry a little bit more and avoiding bad looking geometry. And I will increase this minimum points to 10 and increase this for maybe 0.01. This way we will have a little bit cleaner, deformation. And yeah, as you can see, this is before the delta mesh, and this is after. This is looking a bit better. And now we can do the simulation based on that. Let's increase another version and calculate the simulation. Okay, so the simulation is finished and now it's looking good. Let's see with colors. So as you can see, the simulation is looking much better from the previous version. And let's move it. With this fast movement, you can't see any issue. And yeah, this is looking really cool. Let's write like 15 frames per second. And yeah, we are having like clock is dragging a bit more, and the back is not intersecting. The side panels is looking good. The bands is much better. So yeah. Oh, sorry. Yeah, I mean, it's overall it's looking good. So in the next chapter, we are going to do some post simulation fixes, and we'll make sure we have a clean geometry. After that, we will point deform the original geometry with this one, and make sure we are having a good geometry to export.